Hello and welcome to my science tutorials. In today's video, we want to look at what collinear points are. Alright, so let's begin. Now, if we look at this diagram, we have some lines that are joined in a pattern to form this four squared shape, and then we have another line from the middle, A to C. Now, there are some points on this line, so we see point A, B, C, D, E, F, and G. Now, let's now define what collinear points are. Collinear points. So when we talk about collinear points, they are points that can be found together on a straight line, or they are points that lie on the same line. So it means if I take, let's say, line AB, I can see point A, point G, and then point B on that line. So the points A, G, and B become my collinear point because they can be found on a straight line. Now if I look at A, E, and C, that is also another straight line, and there are 3 points on it. So I also have A, E, and C. These are also collinear points. If I look at the line, let's say D, F, and C, they are also collinear points since we have all those points on one straight line. B and C are also collinear points because they are points on a straight line. So B and C, the same way we have A and D are also collinear points. So basically, collinear point is just you have a straight line, you have points, let's say A, B, and C on it, they become collinear points. Now if you have two lines joined together and one point is here, one point is here, let's say this is D and this is X. Now these 2 points are not collinear points because they are not on a straight line, but they are on different lines, so they are not collinear points. Now let's look at how we determine whether some points are collinear or not. Now there are 3 ways to do that. The first one is to use the distance formula, which is what we'll be looking at in today's video, and in the subsequent video we'll be looking at the other ways of calculating collinear points. The second way to do that is to use the slope formula or the gradient formula. And then the last way of doing this is the area of triangle formula. But like I said, for the purpose of this tutorial, we will be looking at the distance formula. Now, for the distance formula, if let's say we have point A, B, and C, let's say this is a straight line, we have a point, let me use a different color. So we have a point here A, another point here B, and another point here C, and this point A, B, and C are said to be collinear. Then it means the distance AB plus the distance BC should be equal to the distance AC. So I take that again. So if the point A, B, and C are collinear, it means the distance AB, so AB here, and then the distance BC, if we add the two, it should be equal to the distance AC at the bottom over here. Now we know that to calculate the distance of 2 points, let's say A and B, this is equal to the root of the coordinates x2 minus x1 squared plus y2 minus y1 squared. So this is the distance formula, and this is what we'll be using to calculate what collinear points are. Alright, so with this basic introduction, let's go ahead and look at some questions on collinear points. So we have to find if the points x, y, and z are collinear given their points -3, -1, -1, 0, and 1, 1 respectively. Alright, so let's write down our solution. So we have the points x with the coordinates -3, -1, and then we have the point y with a coordinate -1 and 0, and then we have the last point z, +1, +1. All right, Now we were asked to find if the points x, y, and z are collinear. Now because we are using the distance formula, it means that if the points x, y, and z are collinear, then the distance of xy plus the distance of yz should be equal to the distance xz. So it means the distance from the point x to y and the distance from the point y to z should be equal to the distance from x to z. Alright, so let's look at how to calculate that. So I'll do it step by step. So let's calculate the distance xy. So the distance xy is equal to, and we have into bracket, s2 minus x1 squared plus y2 minus y1 squared. Now let me label my coordinates. So this is my x1, y1 in this case, and this is my s2, y2. So that means that I have over here my s2 is -1 minus my x1 is -3, so it becomes -3 here squared, plus plus my y2 here is 0 minus my y1, which is -1, so -1 squared. So this becomes -1 minus -3, that will become plus. So -1 plus 3 will give us 2. So I have 2 squared here, plus this is +1, -1 is +1, and then +1 squared over here. So I'm going to have 2 squared is 4, and then 1 squared is 1. So I'm going to have √5 as my answer over here. So the distance xy is √5. Alright, so let's go ahead and calculate the distance yz. So the distance yz is equal to, I have root of x2 minus x1 squared plus y2 minus y1 squared. Alright, so in this case, because we are starting with a point y and z, then this now becomes my x1, my y1, this becomes my s2, my y2. So this is equal to the root of my s2 is 1 minus my x1, which is -1, so -1 squared, plus my y2 is 1 minus my y1 is 0 squared. So this is equal to 1 minus -1 will give me 2, because this becomes plus, so it becomes 2 squared here plus into bracket 1 squared, and this is equal to 2 squared is 4 plus 1 squared is 1. This gives me √5 as my answer. Now this is √5, this is √5, so it means that just before we calculate the distance xz, it means that √5 for xy over here plus yz, which is also √5, this will give me 2√5 as my answer. So I'm expecting that my distance xz will be equal to 2√5, and if that is the case, then I know that my 3 points x, y, and z are collinear. Alright, so let me go ahead and calculate the distance xz. So I'm just gonna erase this and this guy. Okay, so the distance xz will also be equal to the root of x2 minus x1 squared plus y2 minus y1 squared. So the distance xz will be equal to, now because my x is the first coordinate over here, my first point over here, the coordinates here become my x1, this becomes my y1, and because the second point is z, this becomes my s2, y2. So I have over here the root of x2, which is 1, minus x1, which is -3, squared, plus my y2, which is also 1, minus my y1, which is also -1 squared. So the distance xz is equal to the root of 1 minus minus 3, that will give me 4. So 4 squared plus 1 minus minus 1 will give me 2 squared. So I have over here 4 squared is 16 plus 2 squared is 4. And if I add this will give me root 20. Okay, and root 20, you can solve it as basically this is like 4 multiplied by 5, and then the root of 4 is 2, so you bring that outside, so it becomes 2 root 5. So this is our answer. We have 2 root 5 as our answer. Because the distance xz is 2 root 5, and then the distance xy plus the distance yz is also root 5 root 5. If you add, you get 2 root 5. It therefore concludes that the points x, y, and z are collinear. Alright, so let's have a look at another example. We are to show that the 3 points P 2 4, Q 4 6, and R 6 8 are collinear. Alright, so let's write down our solution. Now, for us to show that the points P, Q, and R are collinear, it means the distance between PQ plus the distance between QR should be equal to the distance PR. Alright, so I'm going to do this straightforward. So the distance PQ will be equal to the root of x2 minus x1 squared plus y2 minus y1 squared, then plus the root of same thing, x2 minus x1 squared plus y2 minus y1 squared to be equal to the root of s2 minus x1 squared plus y2 minus y1 squared. Now when you're doing this, be very careful not to confuse the coordinates of your point. Alright, so let me take PQ first. Yes, P and Q. So let me do that first. So if I do that, this becomes my x1, my y1. This becomes my s2, my y2. So this will be equal to the root of my s2 is 4 minus my x1 is 2 squared plus my y2 is 6 minus my y1 is 4 squared. Now plus, okay, so I can go ahead and erase these guys. Okay, now I'm at QR, so that will be equal to the root of, for QR, this becomes my x1 y1 s2 y2. So my s2 is 6 minus my y1, sorry, my x1 is 4 squared plus my y2 is 8 minus my y1, which is 6 squared, is equal to the root of, okay, so now I carefully erase this. Okay, I can maintain that. So this will still be my y2. This becomes my x1, my y1 now, since I'm using P and R. So my s2 is 6 minus my x1, which is 2 squared, plus my y2, which is 8 minus my y1, which is 4, now squared. So this becomes the root of 4 minus 2, that will give me 2, so it becomes 2 squared, plus 6 minus 4 will give me 2 squared, plus the root of 6 minus 4 will give me 2 squared, plus 8 minus 6 also give me 2 squared. This is equal to, then I come to this side, 6 minus 2 will give me 4 squared, plus 8 minus 4 will give me 4 squared. So I have over here 2 squared plus 2 squared, so this will give me 4, this will give me 4, and that will be root 8 at this point. So I have over here root 8 plus this will also give me root 8 is equal to, this side will give me 4 square is 16 plus another 4 square, which is also 16. So that will give me root 32. And then root 32, say this is root 8 plus root 8 is equal to root 32 can be written as 4 multiplied by 8, because 4 multiplied by 8 will give me 32, and I know the root of 4 is equal to 2, so this becomes over here root 8 plus root 8 is equal to the root. This will become 2 squared, so it will take care of the root, so it comes outside 2 root 8. So we can see that root 8 plus root 8 is equal to 2 root 8. And because PQ plus QR, which is root 8 plus root 8, is equal to 2 root 8, we therefore conclude that the points P, Q, and R are collinear. Now, if you look at it very well, over here, this can also be your answer, but we try to rewrite it in a way that it is easily visible for you to understand. So you try to rewrite it to have the same number under the root, so root 8, root 8. So you try to convert your root 32 to root 8 so that it can be easily identified. So over here we have root 8 plus root 8, so this side will give us root 8. So let me do that. So root 8 plus root 8 will give us 2 root 8, and this is equal to this side, which is also 2 root 8. So we can see that the left hand side is equal to the right hand side, and so the points P, Q, and R are collinear points. So thank you so much for watching, and in the next video we'll be looking at how to calculate collinear points using the gradient or the slope formula. So thank you once again for watching, and I will see you in the next video. Bye bye.